Problem number 9, let S be the maximum value of W cubed minus 3W subject to the condition that we have this. Find GF of S. Okay, again, we use two important things also before the exam. I told them at first differentiation and drawing approximately this diagram. If I differentiate, it will be 3W squared minus 3, and we want to see it is equal to 0. Then 3W squared is 1, W equal to positive negative 1. So in W1 and W negative 1, different derivative is 0. So in 1 we have what? 1 minus 3, negative 2. In negative 1 we have what? 3 minus 1, 2. So it is 2 here. Negative 2 in these two values. We have this. Okay, and we know for large W it will be positive infinity. So for 0 it will be 0. So it passes through this. And it will be something like this, approximately. It's not important. Now it says W4 plus 9 is less than or equal to the 10W squared. If we take to left side, it is equivalent that it is less than or equal to 0. Consider W squared equal to T. Then T squared minus 10T plus 9 is less than or equal to 0. So T minus 1, T minus 9 is less than or equal to 0. So we conclude that the roots are 1 and 9. It is this function. It is less than or equal to 0. So between the roots. So T should be between 1 and 9. T is what? Is W squared is between 1 and 9. So absolute value of W is between 1 and 3. So W can be between 1 and 3 if positive, or if it is negative, less than equal 1, greater than equal negative 3. Now, the W from 1, 3, for example, 3 maybe, yes, it is here. From this part we can have. And W negative 3 to 1, if we place negative 3, it will be something like here to this part. And if we want to check that the maximum is this, we should place this number, check these two. If you consider negative 1, it will be 2. If you check 3, it will be 3 cubed minus 3 times 3. It will be 27 minus 9, which equal to 18. So the answer, it says GIF because it is integer. Floor of that is also 18. So the answer is 18. So drawing approximate diagram and also consider derivative. As I said before, exactly 2 days before the exam, consider the derivatives Lagrange multiplier. It was useful in all parts, junior, senior, and open section. There are also some other ideas I will release in other videos. And if you had any question, feel free to send message to my WhatsApp number in the description and comments. Problem number 10, in the quadrilateral ABCD below, it is given that AB equal to BC equal to CD and ABC equal to 80 degree, okay? BCD equal to 160, this angle. It says ADC is X, so we can say, for example, it is Y, it is 160 minus Y. It says find the value of X because the whole term BCD is 160. We can write like this. We should find X. Okay, here we can say it is 80. It is an isosceles triangle. So 180 minus 80 is 100. So it should be 50. And this one should be 50. Let me erase if it's possible. No. Okay, so let me write 50 here. Equal to 50, and 160 minus 50 is 110. Okay, we can say it is, we said 50, 110, 80. Okay, so here we say it is isosceles, this equal to this, 50 plus 110, 160. So 180 minus 160, 20 is left, so it will be 10. It will be 10, and this part will be 70, this part 10, and okay, 70 plus 50, 120, so it will be 60, and it will be 60. So if I call this one P, and I use sine rule in PAB, then I will have what? Let me write this term as, for example, T. So T over sine 60 equal to AP over sine 70. And also in triangle PCD, if I use again sine rule, it is equal to T by assumption of the problem, t over sine 60 equal to PD over sine 110. If we divide, TT will be cancelled, sine 60 will be cancelled, sine 70 equals sine 110 because their sum is 180, so equal to AP over PD. So we conclude AP equal to PD. Now, because AP equal to PD, it is 60, it is 120. So in this triangle, 180 minus 120, 60 over 2, it is 30, 30. Also, we prove it is 10 because of isosceles triangle. So it will be 10 plus 30 equal to 40. So here we've used only sine rule. We didn't use any important formulas. But as I said before, there are around 50 important formulas in geometry that are useful from qualifying level up to IEM. And also for round 2 problems, you can use them. Also, I released some round 2 problems of senior, junior, and open section. You can see I will use these things and the formulas that are important. Problem number 11, let ABC are B integers with AB plus C 49 and A plus BC is 50. Find the largest possible value of ABC. So here, look, we have integers, so we should pay attention. If we subtract this from this, so A plus BC minus AB minus C equal to 50 minus 49, which will be 1. So if subtract this minus this equal 50 minus 49. Now if we factor from A, it will be A 1 minus B. If we factor from C, B minus 1 equal to 1. Now if I factor from B minus 1, it will be C minus A equal to 1. So both of them are positive 1 or both of them are negative 1. If both of them are negative 1, B minus 1 is negative 1, so B is 0. So in this case, also we should check that is it good or not. But because if we consider this case, it will be better. So we don't need to check that does it satisfy or not. B minus 1 is positive 1. B equal to 2 because we want to find the largest possible value of ABC. Here 0. For the second one, we find a large positive number. So B is 2. C minus A is 1. Also, if you use this, for example, equation, A plus BC. A plus BC is 2C we have, because B is 2 in this case, is 50. Now, here if I add these two terms, then I have 3C equal to 51. And if you divide both sides by 3, it will be 17. And A is C. If you take A, negative A to right side, positive A to left side, C is C minus 1 is A. So A is C minus 1, which is 16, and B is 2. So you see that it satisfies all of them if you replace. In this case, A, B, C will be what? A is 16, B is 2, and C is 17. If you multiply, it will be 544. Okay. Problem number 12, find the largest possible value of absolute value of A plus absolute value of B, where A and B are co-prime integers. A and B are integers which have no common factor larger than 1. It means this, such that A over B is the solution of the equation below. Okay, so also for previous problems, I told to my students one thing that is useful for solving this problem, raising to the power of 2. The second thing you should pay attention when you have, for example, a square of something, consider it as A. It is useful in AIME, also in Hong Kong problems, also for 2022. You can use this. Okay, so A equal to root x plus 1. Now, if we raise both sides to the power of 2, A squared will be x plus 1 and x will be A squared minus 1. And if I replace here, it will be 4x, 4a squared minus 4 plus 5 minus 4a plus root x will be a squared minus 1 plus 2 minus 2a equal to 1. And if we simplify, it will be 4a squared minus 4a, 5 minus 4 plus 1 plus a squared minus 2a plus 2 minus 1 plus 1 equal to 1. And then we can conclude it is what? This term 2a minus 1 squared. And this term is what? A minus 1 squared. So we can say absolute value of 2a minus 1 plus absolute value of a minus 1 equal to 1. Again, as I said, when you want to solve these problems, also in AME, in AMC, you should do what? You should consider, draw it approximately. So the important points are what here? It is 0 when a equals to negative 1 over 2, and here for 1. So these 2 points are important, 1 over 2 and 1. So if a is greater than equal 1, then we have left side. We want to consider only left hand side, this part. It will be 2a minus 1 plus a minus 1, which will be 3a minus 2. If a is greater than equal 1 over 2, less than 1, it will be 2a minus 1 plus negative of this. 1 minus a will be a. And if we consider a less than 1 over 2, it will be 1 minus 2a plus 1 minus a equal 2 minus 3a. If I want to draw it, if I consider 1 over 2 here and 1 here, they have this point, and between them we have a. If I draw with pink, you should draw it approximately as I said. Here after that we have this around the we can say the gradient is 3. Before that the gradient is negative 3, and for example for 0 it will be what? 2. Okay, so it exactly carries here. So we want to see when it is equal to 1. So we have 2 points that is equal to 1. So a can be 1 or this one. The coefficient, the equation of this is 2 minus 3a. So 2 minus 3a equal to 1, this intersection. So 2 minus 1 is 1, take it to right side, 3a, so a is 1 over 3. So we find 1 and 1 over 3 for a. Now we can say what? A was what? A was, x was a squared minus 1. X, a squared minus 1. So for 1, for the case that a is 1, it will be 0. For the case that a is 1 over 3, 1 over 3 squared minus 1, which equal to 1 over 9 minus 1. And 9, 1 minus 8 minus 9, it will be minus 8 over 9. The problem says consider absolute value of numerator plus denominator. For this one, it will be 8 plus 9, 17. For this one, that a is 1, a squared minus 1, 0. So if you want to consider, it will be 0 over 1, and this one will be greater, absolute value of negative 8 plus absolute value of 9. So the answer is 17.